Okay, so the recording is started and we are at somewhere here. Temperature stress strain. Temperature stress strain. Okay, good. Before starting the session, please tell me few points. Please tell me few points, few formulas. Everybody has to do that. Huh? Either you can unmute, you can say directly, or you can type in the chat box. When thermal stresses are induced in the structural member, when thermal stresses are induced in the structural member, when does thermal stresses are induced in the structural member? It is just a wake up call. Tell me, you can unmute or you can tell me when the thermal stresses are induced in the structural member. Fast. Sahil Dangi, Krishna Nikam, both side of the array. बोथ साइड व्हेन आई एम आस्किंग यू व्हेन कब होता है बोथ साइड कहाँ होता है ये नहीं पूछ रहा वेयर नहीं पूछ रहा हूँ कुछ भी आर यू गेटिंग माय क्वेश्चन एवरीबॉडी व्हेन डज थर्मल स्ट्रेसेस आर इंड्यूस्ड everybody has to talk to me because maybe today it's last lecture for this unit if you respond me properly. Let's begin with Ahir Abhijit Bagulom. When material rapidly heated or cooled, कुछ भी काही पण झोप नाही झाली का रे कुणाची सिंपल क्वेश्चन आहे आपण त्याच्यावरती एक तास डिस्कशन केलं स्लाइड नंबर 1 when a material is rapidly heated or cooled अरे कुछ भी if it is rapidly heated or cooled it may expand or contract ना कुछ भी come on everyone परत तेच both side free सुरुवातीतून आहे हाउ मच सिरियस यू आर अबाउट द लेक्चर्स सिंपल क्वेश्चन है इट इज वेरी बेसिक एक्चुअली आई एम विलिंग टू आस्क समथिंग डिफरेंट बट आई गेस द सिंपल क्वेश्चन विल मोटिवेट यू दैट्स व्हाई आई आस्क दैट क्वेश्चन स्टिल यू आर स्ट्रिक्ट लेट मी आई गेस कोण उत्तर देईल ऋषिकेश सौरभ देवरे ऋषिकेश आहेर सौरभ देवरे अरे यार असं नका करतो रे एक आहे आणखी हा शीतल जगताप आपण आहात का तिथे
यस सर
हा माझा प्रश्न समजला
यस
हा काय विचारलं मी काय विचारलं चलो मी तुम्हाला सर्वांना उत्तर देतो बोथ साइड पर नाउ टेल मी द आंसर Now tell me the answer. Now tell me the answer. असं नका वागू रे बोला मला उत्तर मिळाल्याशिवाय मी पुढे जाणार नाही एवढं सिंपल क्वेश्चन तर तुम्ही उत्तर देणार नसणार इट इज फेल्युअर ऑफ माइंड नॉट युअर्स what do you mean by temperature stress or how the temperature stress will induced or what do you mean by free expansion tell me आता स्लाइड पण दाखवली आन्सर पण तुमच्या समोर आहे नन साहिल डांगे व्हेरी गुड When the free expansion is restricted, in that case, the thermal stresses will be reduced. Simple. Then next, tell me the formula to calculate free expansion or free expansion prevented. Delta L is equals to delta L is equals to delta L is equals to. It is just a morning call for you, everybody. Good morning call from my end. As you're not wishing good morning to me, so I try to wish you good morning from my end. What is the formula to calculate delta L or free expansion prevented? Delta L is equals to those students who are submitting the assignment timely, they are aware of this. L alpha T. Okay, Saldangi, very good. L alpha into delta T, very good. What is the formula to calculate mm, strain? What is the formula to calculate thermal strain or temperature strain? What is the formula to calculate temperature strain? Only that L get cancelled. Simple. Alpha into delta T. Very good. What is the formula to calculate thermal stress? What is the formula to calculate thermal stress? Strain into modulus of elasticity. Strain into modulus of elasticity. Okay, very good, Sahil Dagi. Nice. Chal. Well, let's. This is only for to recall you where you are, because only few students are submitting the assignments, and they are capable to give the answers. And this is not like the rocket science. Yesterday we have discussed on that, and today I am asking the question on that. So everybody has to be very alert for this. Okay, let it be. Come to the point. We are. I guess this numerical I have given to you for the homework point of view or assignment. So today we'll be starting for this. A steel bar is a square in cross section having a side of 40 mm, 4 meter long, is heated through 75 degrees Celsius with its end clamped before heating. Calculate the thrust exerted by the bar on clamp. Number one, if the clamp do not yield. Number two, if the clamp yield by 0.75 mm. So now here the new terms is coming into the picture, like uh, here it is yielding. Yield is a term which is new for you. Now try to understand what is yielding. So yielding means see, this is one bar and this is another bar. See, this is one bar. Okay. So our first case is if this end is fixed. So this end is fixed. Let me do this end is fixed means if this end is fixed. This end, let it be. If this end is fixed, okay, and this end is free. This end is fixed and one end is free. It's like this. I have to plot this in condition. Okay. So this end is fixed and This end is also fixed. So this is the case of both end is fixed. Okay. There is no gap in between the member and the restriction or the barrier. But if I put that restriction to somewhere else, if I put that restriction or barrier to somewhere else, so the gap in between the rod and the restriction, the gap in between the rod or object and the restriction, the gap in between both the object is called as a yielding or space for the yielding. This is the gap. What does that mean? If I started to hitting this object, okay, if I started to hit that object, it will freely expand. It will freely expand. It will freely expand up to this restriction, this area. Once this gap is filled, once this gap is filled, beyond that the material will not expand. At that instant, the restriction is started to be exert on the barrier or exerted on the material. So that case is called as a restriction to the thermal expansion, or in that case, thermal stresses have started to be built up. The point is, this gap is called as a yielding space, or this is called as the clamp is yield by distance of, say it is L distance, so it is allowed to yield through distance of L. First case. Okay. The case second is, this is one bar, this is another bar, and there is a space, there is a fix. So in the both case, what happen if I'm start to hit this and this? Okay, I'm start to hit this and this. In that case, both will expand towards one another until the gap will fill. Just like example of rail. In the previous numerical, we have conducted a numerical for the expansion of rail. The gap is given as a 3 mm. So that is the gap. So yielding gap is this much. This is a restriction. This is a restriction. The object will not expand on the either side. It has a passage, or it has a freedom to expand in that gap only. Once the gap is fixed or filled, it will not expand further. So once the gap is closed, there is a thermal expansion starts to be built up. Everybody, I guess you are getting my point. What do you mean by yielding? So yielding is nothing but the space in between the object and the restriction. Okay, the gap to which the expansion is to be allowed. Okay, so that is called as a yielding or yielding space. Now coming back to the numerical. Coming back to the numerical. A bar is a square in cross sectional having a side of 40 mm. So B is equals to 40 is given to us. L meter long, so L is given to us, that is 4 meter. It is called as a 4 into 10 raised to 3 mm. It is heated through 75 degrees Celsius. Now here T1, T2 is not given, it is directly heated through 75 degrees Celsius, means delta T is directly given to us. Heated through. So it is here, it is not two temperatures are given, so that we can have a value for the temperature difference. So delta T is directly given to us. Okay. With its end clamp before heating. Now the bar is clamped, means there is a no yielding. Clamp is both end are fixed. So let me put this diagram over here. Okay. If the clamp do not yield, means this is fixed. With clamp, both end are hitting. Calculate the thrust exerted by the bar on the clamp. If the clamp do not yield, this is first case, and second, if the clamp is yielded by 75 mm, 0.75 mm. So this is first case, and this is a gap of 75 mm. So these both cases we have to solve the numerical. So this much material is given to us. Let us have the another point. What is to find? To find To calculate the thrust means force is to be identified. P is to be identified when the clamp do not yield, and second is the clamp is yield by 0.75 mm. I guess whatever the data given to us, everybody is known. Everybody understood the numerical, what exactly they have given us and what they are expecting as an answer. Okay, I guess everybody is clear. If it is clear to each one of you, then give me a clear in the chat box. अगर आपको न्यूमेरिकल का स्टेटमेंट समझ में आया है तो आप लोग मुझे क्लियर या फिर थम्स अप चैट बॉक्स में शेअर करो. जर तुम्हाला न्यूमेरिकलचा स्टेटमेंट समजलं असेल तर तुम्ही थम्स अप शेअर करा चॅट बॉक्स मध्ये. Everybody, am I audible? Gadgi Shruti, okay, good. Shital Jagtap, Pansare, okay. So most of the people understood what is the statement for the numerical. Good. Let us move towards the P identification. Try to understand the numerical first. This is the given data. This we have to identify. Now this is the point of P. Okay. Let us tell me if I have put the first case over here. Okay. If the clamp do not yield. Now, if clamp is do not yield, so we have to identify P. So, in order to identify the P, what we can do? So, P is the term which is related to the stress. That is, stress is equals to force per unit area. Only stress is equals to force per unit area. Or whenever we are talking about the thermal stresses, in that case, the P term will be come into the picture for the temperature stress strain. Okay. And P is also P is equals to PL upon A. That is delta L is equals to PL upon A. So what we have to identify, how much amount of the restriction is provided over the bar due to this temperature difference. How much amount of the restriction is provided or free expansion is prevented by the rod due to that much of the temperature difference. Let us identify this. Let us identify this. Case number one, if the clamp do not yield. Clamp do not yield means clamp is fixed. So clamp is fixed means there is no chance to expand. There is no free expansion. There is no free expansion. There is no chance for the expansion. But because of the temperature difference, how much free expansion is prevented, that we have to calculate. So delta L is nothing but free expansion or free expansion prevented. So free expansion is given by delta L is equals to L alpha T. Let us calculate L alpha T. So here it is a delta L is equals to L into alpha T. So we do have a L, it is 4, alpha 11.5 to 10 raised to minus 6, and temperature difference is equals to 75. Please go ahead and calculate the value of delta L of T, that is free expansion prevented. Tell me delta L of T or delta L is the term. It is a free expansion or a free expansion prevented by the restriction based on this. Everybody, please. Are you getting my point? My question is right now whatever we are calculating delta L. So what is the delta L? Delta L is a free expansion or free expansion prevented by the restriction. Everyone. Pushna Nikam. Is it possible for anybody to answer the question? Delta L, what is the delta L in first case? Is it a free expansion or free expansion prevented by the restriction? Can anybody? Sahil Dangi? What I am talking to you, you are getting my point or not? Sahil Dangi, how could it be it is free expansion? Free expansion means what? There is no restriction to the, there is no restriction for the expansion. In that case, we can say it is a free expansion. You know, which is that case right now? It is a case where the both end are fixed. So does it a free expansion? It is. It is. Free expansion is prevented by the restriction. Na? See, those students who are talking to me or who are replying to me, na, I will consider them as your representative, because from this I come to know what you are getting. Everybody, I have to take a name of everyone, I guess. Ahir Abhijit, Ahir Abhijit.
Yes, sir.
मी काय बोलतो समजतंय का तुम्हाला? तुम्ही रिप्लाय करत जा, मला असं शांत बसलेलं नाही चालणार. बागुलोम,
Yes.
मी काय बोलतो समजत असेल तर हो बोला, समजत नसेल तर नाही बोला. नो इश्यू. कारण फर्स्ट युनिट आपण लवकर संपणार आहोत आणि त्याला 15 लेक्चर्स घेतोय. त्याच्यावरती पुढचे सगळे युनिट डिपेंड आहेत. घाडगे श्रुती,
येस सर.
मी काय बोलतो समजतंय?
हो सर.
Good. शीतल जगताप,
Yes, sir.
बोलत चला.
Oh.
सोनवणे धनंजय, सोनवणे
Yes, sir.
धनंजय, मला रिप्लाय करत चला. मी जे बोलतोय फक्त मी बोलतोय आणि तुम्ही ऐकताय असं होता कामा नये.
हो सर.
सोनू संसारे,
येस सर.
रिप्लाय करायचा. काय चुकीचं असेल बरोबर असेल त्याच्या पलीकडे काही होणार नाही, पण रिप्लाय करायला लागेल. अंजली संत,
Yes, sir.
रिप्लाय करायचा. ठीक आहे. दिव्या आहिरे,
येस सर.
तुम्ही ऍक्च्युली नवीन जॉईन केला आहात आणि तुम्ही अबसेंट पण खूप असतात. थोडं लक्ष असू द्या. यू हॅव टू बी व्हेरी फोकस. यू हॅव एक्सपिरियन्स व्हॉट हॅपन इन द सॉम इन द डिप्लोमा लेवल. सो यू आर व्हेरी मच अवेअर ऑफ दिस सब्जेक्ट.
Yes, sir.
ट्राय टू बी ऍक्टिव्ह. कल्याणी चव्हाण,
येस सर.
यू हॅव टू बी व्हेरी ऍक्टिव्ह. ओके.
येस सर.
कृष्णा निकम,
येस सर.
फक्त थम्सअप देऊन चालणार नाही, बोलायला पण लागेल. ठीक आहे.
हो सर.
निलेश कुवर,
Yes, sir.
हा व्हेरी गुड. याला बोलतात आवाज. असे याच आवाजावर उत्तर द्यायचे. ठीक आहे. नूतन कचवे,
येस सर.
रिप्लाय करायला लागेल, ऍक्टिव्ह राहावं लागेल. थोडा कन्फ्युजिंग सब्जेक्ट आहे.
Yes.
पानसरे आविष्कार,
येस सर.
ऍक्टिव्ह राहायचं, फक्त प्रेझेंटी नाही लावायची. ऍक्टिव्ह राहायचं, कन्व्हर्सेशन करायचं. काय होत नाही. चुकीचं असेल बरोबर असेल, दुसरं काही नाही होत. ऋषिकेश आहेर,
Yes, sir.
active participation is there. Active participation should be there. Okay.
Okay, sir.
Sai Dangi, you are very active. Little bit focus is required. Okay. Saurabh Devre,
Yes, sir.
आज शांत आहात तुम्ही. आज शांत आहात, लक्ष नाही वाटतं.
नाही सर, आहे सर असे.
ठीक आहे. तर मला कळतं लगेच काय चाललं तिथे. ओके. सो कमिंग बॅक टू अवर पॉइंट अगेन. So what is the delta L? Can anybody tell me? What is the delta LT? Either this is a free expansion or free expansion is prevented. What is that? Free expansion or free expansion is prevented? What is that? Free expansion or free expansion is prevented? What is that? परत शांतता. दिस इज, अरे चॅट बॉक्स मध्ये बोला किंवा रिप्लाय करा, काहीतरी करा. डेल्टा एल इज व्हॉट? इट इज फ्री एक्सपेन्शन ऑर फ्री एक्सपेन्शन इज प्रिव्हेंटेड. Already the answer is given in the slide itself. It is free expansion prevented. So how much it is? Please go ahead and calculate the value for delta LT and tell me the answer.
3.55.
3.55.
नाही 3.45.
3.45. Okay. The answer is correct. 3.45 mm is a. It is free expansion prevented. Why free expansion is prevented? If it is, I'm telling you, it is free expansion prevented or expansion prevented. Why it is free expansion prevented? Can anybody tell me? Try to understand the concept. It is very important. That is why I'm taking much time over here. Because it's both end are fixed. Clamp do not yield. Clamp do not yield means clamp is fixed. Okay, so if it is delta L or free expansion is prevented, now because of that delta L or free expansion is prevented, there is a thrust force is acting. Thrust force is acting means what? Now over here, if the free expansion is prevented, in that case, the wall or the restrictions or barrier will starts to produce a force, that is retaining force or compressive force on that structural member indirectly, which is trying to keep the bar in the equilibrium condition, which is trying to keep bar in the equilibrium condition. Free expansion is prevented means whatever the force internally is there, it is trying to pull that uh, clamp outside, but some force is trying to keep them to a certain position, to equilibrium condition, means there is a compressive thrust is acting on that member. Are you getting me? या मेंबरचं फ्री एक्सपेन्शन जरी होत असलं, या मेंबर मध्ये एक्सपेन्शन प्रिव्हेंट केलेलं जरी असलं, तरी त्या केसमध्ये होतं काय की दिस मेंबर ट्राइंग टू एक्सपांड बट दिस प्लेट इज नॉट अलाउइंग टू एक्सपांड इट फ्रीली, so there is a compressive force is acting on that member, so that is nothing but a thrust force is acting. So what is the role of that thrust force we are looking for? Okay, so because of that thrust force, the expansion is prevented. As I told you, the expansion is prevented by the clamp. The clamp produces the thrust force, that is a compressive thrust force. You can see the nature. This is a compressive nature. It produces the compressive nature. Because of that, the compressive thrust is developed. What is the compressive thrust and how to calculate the compressive thrust? That is equals to compressive thrust means force is equals to, as stress is equals to force per unit area. Stress is equals to force per unit area. So stress is equals to force per unit area. That means force is equals to stress into area. As stress is equals to force per unit area, so stress is equals to force per unit area. So force become stress into area. So which type of the thrust is this? It is a compressive thrust. So that P, it is nothing but P. Which type of the stress is induced? It is a thermal stresses. The area is given to us as it is square bar and its dimension is given to us. We can calculate the value for the area. Let us identify the P. Compressive thrust is nothing but P. It is a P. What is the formula to calculate the temperature stress? It is modulus of elasticity into alpha, that is modulus of elasticity into alpha into delta T, and area is equals to the, if the parameter is known to us, that is square bar and square bar, it is having some dimension, that is B is equals to 40 and it is a square bar, so 40 into 40 will be the area. Let us calculate the value for P. P as it is, E is a 200 into 10 raised to 3 is given to us. P 200 into 10 raised to 3 is given to us. Alpha is 11.5 into 10 raised to minus 6 is given to us. Delta T is 75 and area is equals to 40 into 40 or 40 into 40 into 40. So that will be the area. So please go ahead and identify the value of P and tell me the answer. Tell me the answer.
27,600.
27,600. Well, let me check the answer. Anybody is having anything different answer?
27,600.
Anybody is having any different answer? I don't know the answer. Huh. Somebody has given Ahira Bijit, na? 27,700. Good. Let me check. Somebody has raised the hand. Anjali Sant, you have raised the hand. Do you have any doubt query? Anjali Sant, you have raised your hand. So do you have any doubt query? 27,700 answer. Let me check the answer. I don't know the answer. Okay. So it is 27,700. That is 276. 27,700 27.6 kilonewton. Am I right? So that would be the answer. Very good. This is a case of first. I guess this clear is clear. This case is clear to everybody. Now, in the similar way, we are going to calculate the case two. But in that case, there is some variation. So, what are the variation? Let us have a look. Now, the case is two. When the clamp is yield by 0.75 mm. Now my question is, if the clamp is allowed to yield by 0.75 mm, means what does it means? It means initially there will be some free expansion. Initially there will be some free expansion, and after that free expansion, once the gap is filled by 0.75 mm, after that there will be a free expansion prevented by the clamp. So 0.75 is a free expansion. So we are not going to consider that. So accordingly, we have to subtract that from the free expansion. Okay. So let us find out the value for the free expansion. Expansion prevented by the clamp. So delta is equals to L into alpha into delta T. L into alpha into delta T means it is a free expansion. Okay, it is a free expansion, but actual free expansion is gap. So whatever the free expansion is there, once we have subtracted the gap, in that case the remaining would be the free expansion prevented by the clamp is there. Are you getting my point? L into alpha into delta T is a free expansion. Say it is 10 mm. But at 2 mm, there is a restriction. So how much free expansion is prevented? That is 8 mm. 10 minus 2 will be the 8. So free expansion will be equals to L into alpha into delta T minus of gap. So do we have a L into alpha into delta T? So L is a 4000, alpha is equals to this much, and T is equals to 75. Gap is 0.75 mm. From that, please tell me the answer for free expansion prevented. Please tell me the free expansion prevented. Everybody has to calculate.
2.7.
2. Compressive thrust is equals to stress into area. So compressive thrust is equals to stress into area. So 14 to 14. We can have 40 square or 14 to 40. So this we have to. अरे हॅलो,
Yes, sir.
अरे कनेक्शन डिस्टर्ब झालं होतं का? कनेक्शन डिस्टर्ब झालं होतं का?
हो सर.
Yes, sir.
तुम्हाला स्क्रीन
हो सर.
स्क्रीन दिसते का माझी?
नाही.
No, sir.
नाही सर.
राईट, एक मिनिट हा. मी इकडनं कधीच माझा एकटाच बोलवतो वाटतं. एक सेकंड. दिसतंय?
येस सर.
तो हे जेव्हा मी एक्सप्लेन केलंय तुम्हाला समजलं का? हे म्हणजे कनेक्शन असताना एक्सप्लेन झालं की हो की नाही? हॅलो,
परत एकदा सांगा सर.
असं झालं, कनेक्शन ब्रेक झालं होतं. ओके, आपल्याला सेकंड केस सॉल्व्ह करायची आहे. वेन द क्लॅम्प इज yielded by 0.75 mm. ओके, so clamp is yielded by 0.75 mm. What does that mean? One end is fixed and clamp is away from 0.75 mm from the workpiece. So in that case, how much amount of the free expansion is there, that we have to calculate. So free expansion is nothing but, say मेंबरची कॅपॅसिटी असेल 10 mm एक्सपांड होण्याची, पण जर बार 2 mm वरती आहे तर 2 mm चा पहिले गॅप फिल करेल, म्हणजे 2 mm ही फ्री एक्सपान्शन असेल आणि 8 mm जे आहे ते फ्री एक्सपान्शन प्रिव्हेंटेड असेल. तर कसं कॅल्क्युलेट करणार? सो फ्री एक्सपान्शन प्रिव्हेंटेड इज इक्वल्स टू expansion is prevented is equals to free expansion minus gap. So it is free expansion is equals to L into alpha into delta T minus sub gap, that is 0.75 mm. So you have told me the answer 0.20, 2.7 is the answer for delta L. Now second case is, it is similar to that of the P thrust. So because of this prevention, the thrust P is created and that exerts the compressive force on the structural member. So compressive thrust is equals to stress into area. आपल्याकडे स्ट्रेस आहे का? आता या केस मध्ये नाहीये. आपल्याकडे एरिया आहे का? 40 into 40 चा एरिया आहे. स्ट्रेस कसा काढणार? स्ट्रेस इज इक्वल्स टू, that stress is nothing but E into strain into E. So that is strain into E. Temperature stress is equals to strain into E. So इथं आन्सर दिसतात ऍक्च्युअली तुम्हाला. स्ट्रेन इंटू ई. आपल्याला स्ट्रेन कॅल्क्युलेट करायला लागेल. स्ट्रेन काय? डेल्टा एल अपॉन एल. डेल्टा एल किती आहे? 2.7 अपॉन एल 4000 दिलेला आहे आपल्याला. तो दिस इज ई स्मॉल ई, दॅट इज स्ट्रेन इंटू मॉड्युलस ऑफ वेलोसिटी, इट विल बी इक्वल्स टू टेम्परेचर स्ट्रेस. ठीक आहे. जर दोन टर्म जेव्हा येतात आपल्याकडे, स्ट्रेन येतो स्ट्रेस येतो, तर त्याच्यावरून आपल्याला थ्रस्ट कॅल्क्युलेट करता येतो. थ्रस्ट इज इक्वल्स टू स्ट्रेस, स्ट्रेस इज इक्वल्स टू, हे कॅल्क्युलेशन केल्यानंतर आपल्याकडे काहीतरी आन्सर येईल. दॅट यू हॅव टू टेल मी. एरिया आपल्याला दिलाय 40 into 40. सो फ्रॉम दॅट यू हॅव टू टेल मी द कॉम्प्रेसिव्ह थ्रस्ट. पहिले तुम्ही काय करा? स्ट्रेन कॅल्क्युलेट करा. हा स्ट्रेन बरोबर आहे का चेक करा. मला आन्सर द्या. हा स्ट्रेन बरोबर असेल तर मग आपण स्ट्रेस कॅल्क्युलेट करू. Go ahead and tell me the value for delta L upon L, 2.7 divided by 4000. हे बरोबर आहे का सांगा मला आधी.
बरोबर आहे सर.
बरोबर आहे? ओके, व्हेरी गुड. दिस इज स्ट्रेन. So from that we are going to calculate the temperature stress. Temperature stress is equals to strain into modulus of velocity. स्ट्रेन तुम्ही आता कॅल्क्युलेट करा आणि मॉड्युलस ऑफ वेलोसिटीची किंमत आपल्याला दिलेली. टेल मी द व्हॅल्यू फॉर टेम्परेचर स्ट्रेस.
$135.
135. Okay, very good. 135 is the right answer. Now we have a stress. So compressive thrust is equals to stress into area. Stress तुम्ही आता कॅल्क्युलेट केलाय 135. एरिया आहे 40 into 40. तो त्याच्यावर तुम्ही पी ची व्हॅल्यू कॅल्क्युलेट करू शकता का? इफ यस, देन गो अँड कॅल्क्युलेट द व्हॅल्यू फॉर पी. मीन्स 135 into 40. Let me check who has given the answer. Kalyaniche one good, Shital Jagtap good, Nutan Katra good. And please go and identify the value for thrust. 130.240. Nutan Kashwe is saying 216. So out of there are 216. Let me check. Let me check the answer. Okay, 216 is the right answer. Very good. Now you are getting what exactly there is given in the numerical and how to solve this numerical. Okay. Now we are going to start towards a very important point, that is members are connected in the parallel. This is very important point. Members are connected in the parallel. I'll conduct more 5 minutes. 5 minutes of your. Now, for that, there is a huge derivation is given to you. But in the simple language, try to understand what I mean. See, there is a two friend. One is a copper and one is a steel. There are two friends. How many friends are there and tell me their names? There are two friends. Which are they? Look at the slide. There are two friends. One is a copper and one is a steel. Okay. So, how many friends are there and what are their names? Tell me. How many friends are there and tell me their names? Just simply admit and tell me. Anybody? How many friends are there and what is their name? What are their names? There are two friends. One is a copper and one is a steel. Am I audible? Yes or no?
Yes, sir.
Hello? 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 Hello?
Yes, sir.
Okay. Sahil Dange is saying two friends, one is a copper and one is a steel. Now, what happened? Both friends are the same. Both friends are at the same position. Means in our campus. Both are at the same position. Means I'm very hungry and I wish to go to canteen. But still, he is saying today we are late. We have to go for the lecture, and especially for mind lecture. Okay. So Copper is saying, I am very hungry, I am willing to go to the canteen, and still is saying, today we are late, we have to go for the lecture. There is some lecture is going on, or solid mechanics lecture is going on. Okay. So in that case, Copper is trying to pull. In that case, am I audible?
Yes, sir.
अरे इथे लाईट गेली तुम्हाला कसं आवाज येतो मला? हॅलो everybody. Am I audible? लाइट
Yes,
फ्लक्चुएट
sir.
Yes, sir.
लाइट फ्लक्चुएशन हो रहा है यहाँ पर, इसलिए इंटरनेट का इशू हो रहा है. ओके, so I am here. Two friends are there, both are in our campus. Copper is hungry, he is willing to go to the canteen, and still he is saying that today we are late, we have to go for the SOM lecture. Okay, so now the thing is, Copper is trying to pull the steel and steel is trying to pull the copper. मीन्स कॉपर बोल रहा है चल तू कैंटीन में, और एंड स्टील इज बोल रहा है तू चल क्लासरूम में। ये दोनों चीजें हो रही, लेकिन ये क्या हो रहा है, व्हेन सच अ केस इज ऑब्जर्व ना, copper is trying to give more pull to the steel, but still he is not capable to pull that much. Copper is trying to pull steel at a large extent to that much, because he has a tendency to pull anybody to anywhere. ये जब हा जेव्हा बोले पार्टीला चला फिरायला चला तेव्हा ते होऊ शकतं, त्यामुळे हा जास्त फोर्स लावतो. स्टील जास्त फोर्स नाही लावू शकत, तो इन्सिस्ट होऊन जातो तो. ठीक आहे. त्या केसमध्ये कॉपर स्टीलला ओढतोय आणि स्टील कॉपरला ओढतोय. त्या केसमध्ये कॉपरची तर टेंडन्सी आहे ओढण्याची इथपर्यंत, आणि स्टीलची तर टेंडन्सी आहे इथपर्यंत ओढले जाण्याची. त्या केसमध्ये दोघं मिळून एक डिसिजन घेतात की हा कॉपर स्टीलला इथपर्यंत सेंटरपर्यंत, दोघांच्या सेंटरपर्यंत ओढतो, आणि स्टील हा ओढला जातो इथपर्यंत. त्याची टेंडन्सी किती, इथपर्यंत ओढल्या जाण्याची टेंडन्सी. इट हॅज अ टेंडन्सी टू पुल अप टू दॅट, बट कॉपर इज ट्राइंग टू पुल हिम अप टू दॅट मच पॉइंट. What does that mean? Copper applies a tensile load on the steel up to that much, and steel apply a compressive load on the copper up to that much. I don't know you are getting or not. Try to understand. Try to. Okay. Today it is 10:34. Somebody will wait for you in the next 5 minutes. I will be starting that session very interestingly. This is the last point from that unit, and we will be finishing that on the next lecture. Here it is again. Here it is, the network issue is too much going on. So those who have given the attendance sheet, thank you so much. See you in the next lecture. Tomorrow there will be a last lecture for unit number 1. Those who are nearby to our college, they can come to me for the discussion. You can come to me for the problem solution. We will be having a discussion. If you feel that something is difficult, we can arrange a special meeting for you at your required time. Thank you so much. Have a good day. Have a great day. See you in the next lecture.